Hello students. So today we will be starting the second chapter in physics, the physical quantities and measurement. Last time we were studying the chapter on matter. This time we will be starting this chapter, physical quantities and measurement. Once again, this is one of those chapters about which you have got some basic idea because it was also in a junior class. The first quantity we are going to deal with is density. So what is density? Well, density, rho, is the mass per unit volume. So it's mass divided by volume. Now density is basically how heavy or light a substance is. You can take the same volume of iron and the same volume of water, but you will find that the same volume of iron will weigh or will have a mass much greater than that of water. This is because iron is denser than water. Now there are generally solids which can be classified broadly into two types, the regular solids and the irregular solids. The regular solids are ones which have a specific geometrical shape, like the square or rectangle. Then the cube, you have also heard about cuboids. The difference between cube and cuboid being that in cube the length, breadth and height are all equal, but in cuboids the length, breadth and height are different. Similarly, some surfaces or figures like the pyramid, the kite, these are all examples of regular solids. Regular solids means ones whose area, whose volume can be found out by using specific geometrical formulas. And then there are irregular solids like the one I have drawn here. A real life example could be a piece of stone. They do not have any specific geometrical shape, and thus it is not possible to find their volume by using a mathematical formula. How will we determine the mass of this kind of bodies? Well, mass can easily be calculated by using a physical balance or a beam balance. You place the substance whose mass you are trying to weigh on the pans of the beam balance, whether regular or irregular solid, and then you find out what its mass is. How do we find out the volume? Well, if it is a regular solid, we can find out its volume by using geometrical formulas. Like for a cuboid, the formula is length times breadth times height. For a cube, it is the side cube. But how do we find out the volume of irregular bodies? For irregular bodies, one of the method is this. This is method number 1. We take a graduated cylinder, a cylinder where proper markings are there as to up to what mark the volume is filled. Now in this cylinder we initially fill it with water up to a certain mark, say 60 cc. 1 cc is equal to 1 centimeter cube, which is equal to 1 milliliter. So suppose in this graduated cylinder there is water up to the 60 cc mark, and then you take one of these irregular solids, you tie it with a string, a very thin piece of string, and you submerge it into the graduated cylinder. You shall find that there is a displacement in the reading of the water level. For example, I have taken it to be 73 cc. That means the volume of this irregular body is 73 minus 60, the final reading minus the initial reading, so it is 13 cc. And how do we find out its mass? By using a physical balance. Once you know the mass and once you know the volume, you can easily find out what will be the density of this irregular body. There is another method by which you can do this, which is the method of using an Eureka can. So Eureka can is a can like this, where there is a opening towards the top of the cylinder. So when you initially fill water up to this level, you have to fill it up to the brim. This is called filling up to the brim. That means you have filled the water up to such a level that if you add any more water, maybe a 2 drops more, it will overflow from this area of the can. So that is what the Eureka can principle is. You have to fill it up to the brim. Now you are trying to measure, suppose, the volume of a irregular body, and just like before, you insert it into this Eureka can by tying it with a stone. Once you insert it, the water level will rise and the extra amount of water will drain through this spout. If you place a graduated cylinder here, you can find out how much water has collected here. You can get to know its value from the reading. Once you know this value, then this volume of water is the volume that has been displaced because of this irregular body here. So from there you can calculate what will be the volume of the irregular body, and like before, you can measure its density as well. But that is measuring the volume or measuring the mass of solids. What about measuring the density of the liquids? How do we find it out? Measuring the density of liquids turns out to be pretty easy. So I take a graduated cylinder like this, which is initially empty, and I weigh what is the mass of this graduated cylinder. Say the mass turns out to be ME. This is the mass of the graduated cylinder when empty. And now I fill the graduated cylinder with water up to a level. Say this mark is the 70 cc mark, and this is water. And I again weigh it on a physical balance, and suppose the mass this time turns out to be MW, which is the mass of the graduated cylinder with water. So what is the amount of water I have poured? The amount of water is MW minus ME. And what is the volume of the water I have poured? The volume is 70 cc. So this is basically mass by volume. So from here you can easily calculate what is the density of this particular liquid which I have poured. So measuring the density of liquid is actually pretty easy. Let us consider one numerical. It is provided in your book only. The question says that a measuring cylinder is filled with 50 ml of water. So it is initially filled with 50 ml of water. A solid with mass 16 kg is lowered into the cylinder. The mass of the solid is 16 kg. The water level rises to 58 ml. New level is equal to 58 ml. They have asked to find out the density. Well, what is the mass of the solid? That is 16 kg. What is the volume of the solid? Volume of solid is equal to 58 minus 50 ml. The final level of water divided by the initial level of the water. This is the increase in the level of water, that is the volume of solid. Then what will be the density of the solid? Density will be its mass, that is 16 kilograms, divided by its volume, that's 8 ml. So the density is equal to 2 kg per ml. A pretty simple numerical, but you can get ones of this kind in your exam. The next topic we are going to study is relative density. So you already know now what density is. It is the mass of any substance per unit volume. What is relative density? It is the density of any substance divided by the density of water at 4 degrees Celsius. So suppose I am trying to find out the relative density of iron. So that will be equal to density of iron divided by density of water at 4 degrees Celsius. Now density means mass by volume, so density of the substance is mass of the substance divided by volume of the substance, and density of water means mass of water divided by the volume of an equal amount of water. So if I take 10 ml of the substance, I will take 10 ml of water only, equal volume of water. And since these two volumes are equal, they cancel out. What remains is the mass of the substance divided by mass of water. So relative density can also be defined as the ratio of the mass of that substance divided by the mass of water. This 4 degrees Celsius temperature is important because that is the temperature at which water has got the maximum density. In higher classes you will read something known as anomalous expansion. In class 9 you will study this, and it is due to this phenomena of anomalous expansion that water has maximum density at 4 degrees Celsius. Its density decreases below 4 degree and above 4 degree. This is relative density. Don't get confused if you hear the term specific gravity in your exam. Specific gravity is just another way or another term for relative density.